Imagine, just for a second, sitting at your computer. You open up a basic calculator app, you type in some complex math equation, and you hit enter.
Right, and you get an exact answer.
Exactly. It's perfect, it's precise, and, crucially, you don't even for a millisecond question whether or not that computer just lied to you, you know?
No, of course not. We never do.
Right. Because for decades, our entire relationship with technology has been built on this rock-solid, predictable reliability. Computers do exactly what we tell them to do. But what happens when the machine stops acting like a rigid, predictable calculator and starts acting like a highly persuasive, incredibly eloquent storyteller?
Yeah, that tension right there is the core of what we're unpacking today. The software we use on a daily basis has fundamentally changed, but our psychological approach to it just hasn't caught up at all.
Not even a little bit.
Right. We are taking decades of blind, unquestioning trust and walking straight into a completely new, totally unpredictable environment.
And that environment is exactly what we're exploring today. You sent us this fascinating stack of notes, your own research, and a really incredible primary presentation brought to us as Dr. Christophe Delong at Kinexa Formation present, and it's titled AI and the Illusion of Determinism.
It's a great title.
It really is. And the mission for this deep dive is to basically help you, the listener, unlearn everything you thought you knew about interacting with computers. We're going to explore why your deeply ingrained trust in software is actually making you incredibly vulnerable to modern AI.
Vulnerable, yeah, because the title of that presentation, The Illusion of Determinism, it perfectly captures the trap we are all falling into right now.
The trap of just assuming it works like it always has.
Exactly. To understand why we're so easily tricked by artificial intelligence today, we really have to look at the baggage we bring to the keyboard. You mentioned the calculator earlier.
Yeah.
That is what computer scientists call a deterministic system. Traditional software, like the spreadsheets, the word processors, the programs we've used our whole lives, they are deterministic.
Meaning they're strictly rule-based.
Right. If you perform action A, the computer will always, 100% of the time, produce result B.
It's a closed loop. I click save, the file saves. I don't have to wonder if the computer decided to, delete my file because it just felt like it.
Yeah, it's closed, but more importantly, it's a fixed path. There is a definitive, programmed instruction for every single action. But large language models, generative AI, they operate in a completely different universe.
Right.
They are not deterministic at all. They are probabilistic. They're built on these massive neural networks that deal in variable plausibility, not strict rules.
So they don't have a rigid line of code that says, like, if the user asks this specific question, output this exact verified truth.
No, not at all.
Wait, so if I ask an AI a simple factual question like, what year did the moon landing happen? It's not actually going into a database and pulling out 1969.
No, and that is the crucial misunderstanding most people have. It is not looking up a fact. It is calculating the probability of what word should come next in a sequence based on its massive training data.
Oh, wow.
Yeah. It just so happens that the statistical probability of 1969 following the words moon landing was in is incredibly high.
Okay, I'm trying to visualize this difference because it feels massive. So if traditional software is like a train on a fixed track, like I get on the train, pull the lever, and it goes exactly where the steel tracks lead it.
Right, to the station.
To the station. It cannot physically go anywhere else. Is generative AI just like a train that kind of builds its own tracks as it goes?
Not quite building tracks, because even that implies a level of solid permanent infrastructure. It's much more fluid than that.
Okay.
Think of it more like a surfer riding a wave.
A surfer. Okay, I like that.
Right, because a surfer is constantly adjusting, rebalancing, and reacting to the probabilities of the water beneath the board in real time.
Because every wave is different.
Exactly. Every wave is a little different. You can catch the exact same type of wave 10 times, but the specific path the surfer takes to the shore will vary based on those micro adjustments.
That actually makes a lot of sense. And I see the danger there if I'm transferring the absolute unquestioning trust I have for the train onto the surfer.
You're expecting the surfer to arrive at the exact same millimeter of the beach at the exact same time every single day.
Which is physically impossible.
Completely impossible. We have this fundamental misunderstanding of the tool's very nature. AI doesn't follow strict programming rules to arrive at a definitive truth. It uses complex statistics to generate language that simply sounds highly plausible.
But because it's coming from a screen, like from a sleek computer interface, we just inherently trust it as factual.
Right.
Which brings up a really common scenario. When the surfer inevitably wipes out, when the AI gives us a wrong answer or hallucinates a fake legal precedent or a historical event,
Yeah.
my first instinct is just to think, oh, the software has a bug. The developers at whatever tech company will just release a patch next week to fix the hallucination issue.
And this right here is a categorization error that the source material highlights as one of the absolute most dangerous traps for the modern user.
Really?
Yes, hallucinations are not technical glitches. They aren't a software crash. They are not a bug that can be patched out in version 2.0 or 3.0.
So wait, it's not malfunctioning when it lies to me?
Not at all. Hallucinations are an inherent, permanent manifestation of how a probabilistic system works.
Wow.
You cannot expect a software update to, cure the system of its core architecture. When it hallucinates, it is actually doing exactly what it was built to do.
Yes.
Generate a statistically plausible sequence of words.
That's wild to think about.
It is. And this expectation that the tool is technically perfectible, it completely masks the reality. The user just assumes a false fact is a temporary flaw in an otherwise deterministic machine.
And what makes it so incredibly hard to spot those flaws is that when the AI does wipe out, it does it with absolutely perfect form.
Yes, exactly.
Which brings up the second psychological trap from the presentation, the bias of linguistic authority.
Yeah, this is a really fascinating cognitive blind spot. When an AI generates a response, the text it produces is almost always grammatically perfect.
Always. It never makes a typo.
Right. The syntax is flawless, the style is highly structured, and it reads with supreme, unwavering confidence. And the human brain, frankly, relies heavily on shortcuts.
We use the formatting as a proxy for the truth.
Exactly, because historically, if you read a beautifully structured, eloquent, highly detailed 5-paragraph essay, it usually meant the person who wrote it was an expert.
Right. They had to put in the time to learn the grammar, structure the argument, do the research.
Exactly. So we accord the AI an excessive amount of credibility simply because of its linguistic mastery.
The packaging is so shiny and professional that we just assume the product inside must be premium.
We fall for it every time.
Yeah. If you ask an AI to summarize a 50-page PDF and it spits out a gorgeous executive summary with bolded headers and bullet points, the cognitive cost of fact-checking that beautifully written, authoritative-sounding answer is just too high.
It is exhausting to verify. Imagine getting that perfectly formatted summary. To go through and independently verify every single bullet point against the original document takes immense effort.
It feels wrong to doubt it because it looks so fundamentally right.
Which is why we routinely and dangerously confuse linguistic mastery with factual knowledge.
Okay, so if this polished language is essentially just an illusion of expertise, what is the AI actually doing under the hood when it generates an answer?
Well, we need a serious reality check on what AI actually is. The presentation makes it very clear. The AI is not an omniscient oracle. It doesn't know things in the way a human expert knows a subject. It is a linguistic engineering tool designed for one very specific, very narrow function.
Which is?
To maximize the statistical plausibility of the next word. And it will do that even if that word creates a completely false statement.
But why doesn't it just say, I don't know? Like, for example, if I ask it for the biography of a 17th century peasant who didn't actually exist, why does it give me a 3-page life story instead of just an error message?
Because they doesn't know that it doesn't know.
If it doesn't have the data, why lie to me right out of the gate?
It comes down to the fundamental constraints of its architecture. The AI is constrained by its primary mandate. It must predict a sequence. Silence is not its default state.
Interesting.
Yeah, if you ask it a question where it lacks a strong factual truth in its training data, it doesn't have an internal mechanism to feel uncertainty. It doesn't experience doubt.
So it just sees a blank space and feels this mathematical compulsion to fill it.
Yes, exactly. It is faced with a gap, and its programming demands that it fill that gap with the most statistically probable, fluent words available.
Wow.
This is what the presentation defines as a type 1 failure, or an immediate rupture. This is a pure probabilistic failure, and it happens immediately on the very first prompt you give the machine.
So if you're a lawyer, for example, and you ask it for legal precedents to support some niche argument, it will generate what looks like real case law.
Oh, absolutely.
It will invent names, dates, docket numbers, just because that is what legal documents look like statistically.
That is a perfect example of what we call a perfect hallucination. It gives you a response that possesses all the formal characteristics of a truthful answer.
The right structure, the right tone.
The right level of detail.
Yeah.
but the information is completely incorrect or entirely invented, and it's vital to remember the AI doesn't know it's lying.
Right, it has no concept of truth.
Exactly. It is simply generating the continuation that is most probable according to its statistical parameters, completely independent of factual reality.
Okay, so that's the immediate danger. You ask one question, you get a beautiful, confident lie, but your notes from the presentation highlight something that honestly terrifies me even more.
Yeah, the deep chats.
Right, because immediate hallucinations are one thing. But it turns out that having a long, seemingly productive back and forth conversation with an AI is actually where the system fundamentally degrades.
Yeah, this brings us to the type 2 failure, or what the researchers call architectural drift. And unlike the immediate rupture, this isn't a single error that just jumps out at you.
It's more insidious than that.
Much more. It is a slow, inevitable degradation of the conversation as the exchange goes on.
Let's figure out how this works. Is it like a hard drive filling up? Because normally when my computer is full of files, it just gives me a pop-up saying storage full and stops accepting new data.
It's not like a hard drive, no, because a hard drive warns you and simply stops working. The AI's memory, what developers call a context window, is more like a physical bucket with a fixed size.
A bucket, okay.
And to understand this, we need to briefly talk about tokens.
What exactly is a token
Yeah.
in this context?
Think of a token as a fragment of a word or a single syllable. The AI can only juggle a certain finite number of these fragments at any given moment. That is its hard token limit.
Got it.
At the start of your conversation, your bucket is empty. You start pouring fresh, clear water into it. You give the AI your initial instructions, your constraints, the background context of your project, and the bucket holds it all perfectly.
But as I keep chatting, asking follow-up questions, and the AI gives me longer and longer answers, I'm pouring more and more water into that bucket.
Exactly. And because the bucket has a fixed size, to put new water in at the top, the old water has to spill out the bottom.
Oh, wow.
Yeah. As your chat session gets longer, the context window saturates. To accept your new prompts and generate new answers, the system silently, without ever giving you a storage full warning, it begins to eject your initial instructions and the early context you provided.
That is terrifying. It's essentially developing amnesia right in front of you, but it's still talking to you with that exact same confident, authoritative voice.
And the data on this architectural drift is genuinely chilling. The presentation outlines the exact trajectory. When you start the conversation, your coherence is at 100%. The AI understands your full context.
Right.
But after just 10 exchanges, just 10 back and forth between you and the machine, that coherence drops to 75%.
Wait, only 10 exchanges? That's barely getting started on a real project.
I know.
And it gets worse.
Much worse. After 20 exchanges, the coherence plummets to 40%.
40%. Let's put that in perspective. I mean, 20 exchanges is just a normal Tuesday morning trying to get an AI to help format a complex Excel macro,
Exactly.
You're telling me that by the time I'm actually getting to the hard part of the code, the AI has essentially forgotten 60% of the ground rules and the premise of the project I laid out at the beginning.
That is exactly what is happening. The AI is now operating on a severely truncated data set.
That explains so much.
Right. The initial, often crucial information has been ejected to make room for the newer, perhaps less important parts of the conversation.
Which leads to terrible outputs.
It leads to a massive rupture in logic and consistency. And again, to tie back to our earlier point, this isn't a bug.
It's just the bucket.
It's the bucket. It is an ineluctable degradation due to the fact that the probabilistic engine is now working with a fractured memory.
So if the AI's language is so polished that it completely bypasses my critical thinking, and the system is silently getting amnesia 20 minutes into my project, how do I snap out of that? Does the source offer a way to actually use this technology without constantly getting burned?
It does, thankfully. And this is where we have to fundamentally change our approach. The presentation emphasizes a massive metacognitive shift. It introduces the concept of the strategy of systematic doubt.
Systematic doubt.
Right. The key to using AI successfully isn't having a high traditional IQ or being some sort of coding genius. It's about developing a very specific AI literacy.
I really love that phrase, AI literacy. It frames it as a learned skill, like reading or algebra. You aren't born knowing how to do it. But what does that actually look like in practice? Because, I can't just stop using these tools at work.
No, of course not. The core tenet of AI literacy is this: doubt is not an option. Doubt is a mandatory prerequisite for using large language models.
Mandatory doubt. Okay.
An educated user doesn't just hope for an absence of bugs. They exercise continuous, active control over the interaction. And the source provides three specific pillars of defense to do this.
All right, what's the first one?
The first is systematic verification.
Which means explicitly separating the beautiful format from the actual facts.
Exactly. Just because a response is a grammatically perfect bulleted list does not mean it is true. You have to validate any critical facts or claims against external, reliable sources.
So breaking the spell of that linguistic authority.
You have to actively break the spell.
So if I'm using it to draft an important email to a client and it references some statistic, I can assume the statistic sounds plausible, but I have to go to a separate search engine to verify it.
Always. Never skip that step.
Okay, what's next?
The second pillar is active questioning. You don't just passively accept the first answer the AI gives you.
Right, so I need to treat it less like an infallible encyclopedia and more like an overeager intern who might be trying a little too hard to impress me. I have to interrogate the work.
That's the perfect mindset, actually. You demand sources directly from the AI, you ask it for precision, you proactively challenge its affirmations to test its logic.
So if it gives me a confident statement, I push back.
Push back hard. Ask, are you sure about that? Or what is the primary counterargument to the point you just made? Make it justify its probabilistic leaps.
That makes total sense. And what about the amnesia issue? How do I stop the bucket from overflowing during a long project?
That brings us to the third pillar, continuous contextualization. This is specifically designed to fight that architectural drift.
Because in long conversations, you simply cannot assume the AI remembers your initial instructions from 20 prompts ago.
Right. You have to actively manage its memory for it.
So I have to literally re-pour the important water back into the top of the bucket.
You do. You must regularly, proactively remind the AI of your constraints, your goals, and your initial rules.
So like copy and pasting.
Exactly. You might need to copy and paste your original prompt every 10 exchanges just to refresh its context window.
Just to keep it on track.
Because the ultimate takeaway from Dr. Christophe Delong and Kinexa Formation is a fundamental shift in how we view the tool itself. The AI is an assistant for reasoning, not an oracle of truth.
Wow, okay. An assistant for reasoning.
Mhm.
It is a powerful engine for generating ideas, exploring possibilities, and formatting language. But it is not a truth-telling machine.
Not at all.
The final responsibility for the veracity of the information, the actual truth of what gets published or sent to a client or put in a presentation, that rests entirely on your shoulders.
Exactly. Not the machines. The machine doesn't care about truth. It only cares about probability.
It really requires a constant, sophisticated vigilance, doesn't it?
It does. You have to proactively maintain the interaction within the bounds of truth and coherence. It's an active, somewhat exhausting partnership, not a passive retrieval of facts.
Let's quickly summarize the journey we've just taken, because this is a massive shift in perspective.
It really is.
We started by looking at our outdated, deterministic trust in computers. That old expectation that machines are rigid calculators that only do exactly what they're told.
And we unmasked modern AI not as a truth teller, but as a probabilistic engine of plausibility. It's a surfer adjusting to waves, not a train on a track.
Right. We explored the immediate ruptures where the system's mathematical mandate to predict the next word forces it to generate beautifully formatted, perfectly confident hallucinations.
Like inventing fake case law just to fill a blank space.
Yeah. And we looked at the delayed ruptures, the architectural drift, where the AI's limited token memory slowly ejects your vital context, turning a deep, complex chat into a degraded, incoherent mess.
And finally, we armed you with the strategy of systematic doubt. Verifying externally, questioning actively like you would an eager intern, and continuously reminding the AI of the context to manage its amnesia.
It really is the only way to safely navigate this new technological landscape, by moving from blind historical trust to active AI literacy.
Exactly.
Which leaves us with a truly fascinating, kind of lingering thought. We spent this whole time talking about how the machine works and how it fails, but the machine was trained on us.
Right.
It was trained on massive data sets of human language, human writing, and human interactions. So if artificial intelligence is essentially just a mirror reflecting the statistical probability of human language back at us, what does it say about humanity that our most eloquent, highly structured, statistically plausible language is so easily divorced from actual truth?
That is a great question.
Next time you are persuaded by a perfectly polished argument, whether you're reading a formatted output from a machine or listening to a confident human being, ask yourself, are you actually being convinced by the facts, or are you just falling for the fluency?